Good afternoon, ladies and gentlemen. This is Steve Pollmann calling, and it is our pleasure today to host this webinar that's being sponsored by EPI Air. We'll describe the company a little bit more. Matt Baumgartner was going to be facilitating this webinar today, but because of some personal family situations, Matt is unable to help us with that facilitation. So just wanted you to know that Matt was planning on being here today, but because of that situation, he's unable to participate. Just in the way of logistics to get us started, as you see on the screen, there's a couple of ways you can submit your questions. You can do it through the Q&A button located on the screen, or you can text John directly, and you see his telephone number there. And what we'll do is we'll take questions at some breaks in the webinar and then at the end as well. Again, we appreciate your time today and hope that the information is helpful to you. You know, you get this all set up and there we go. Let me begin by indicating that I officially retired from Murphy Brown in May. And they say when you retire, you find a hobby. My hobby has been people and pigs the last number of years, and so I've started a little consulting business that I continue to do a little bit of work in the industry, keep my oar in the water, and to have some fun. And so one of the clients I've been working with is around this whole concept of electrostatic particle ionization. And we've really started working on this concept about 5 years ago while I was with Murphy Brown. So today what we're going to be doing is doing a review of the body of the work. And what we're going to do is talk about the concept in general to introduce to those that may not be familiar with it, provide some updates on where we are with pig performance and its impact on air quality, some recent research that has been done on bacterial and viral reduction load, and then some of the early work that was done in poultry was instrumental in creating the curiosity to do the work while at Murphy Brown, and I want to show you some of the poultry work and then conclude with a bit of a value proposition update. To begin with, I think all of us fully connect with the importance of proper ventilation, but in many cases there's a number of shortcomings in our system. With was ventilation in the late part of the nursery and in the late part of finishing. And so we're looking at technologies that would help us better control that and especially decrease particulates. And there have been technologies that have been evaluated, but with limited success. And then this emerging technology called EPI came along, and EPI is really a patented air cleaning system. So the patent has the novelty statement and the claim that it's specially designed for reducing dust, germs, gases from agricultural settings and other confined spaces. The concept of using ion particle ionization has been used in other industries, but has been relatively limited use within commercial agriculture. The patent is owned by Baumgartner's Envirometrics out of Minnesota. John is the father of that group, and Matt, the son. It's a father-son group that have developed and patented this technology. And it's a bit of a challenge physics-wise to explain it, but in simple terms, what it does is sprays trillions of charged ions into the airspace every second, and then these polarized particles in the air collide with other particles, and then they become polarized, resulting in them attaching and sticking to other surfaces. I'll show you some pictures of that to illustrate that a little clearer, but more than anything, it's really the idea of manipulating the air system and charging the air with with ions. And then by doing so, you potentially are clearing the airspace. So the components of the EPI system are really the four following aspects. The first one is really the power source, and this is what generates the ions that are moved into the corona pipe that I'll show you a picture of in a second, which really energizes the system to start doing the activity. And then this ionized system is delivered through the corona pipes, which is a stainless steel pipe suspended from the ceiling. And you can see how those points come out. So if you were to put your hand up close to that, you would feel actually a little bit of electrical field around those. And then the third and fourth part of the system is a high voltage switch that you can use to turn off or on the system when working on it, and then a motorized winch to move the unit up and down in the operation. Here's a close-up picture of the corona points, and you can see how they come out and shoot into the environmental area. And then a picture more in a nursery, the EPI system suspended about, maybe 2 feet above this nursery pen. And then it's got the winch that makes this go up and down here. And you can see in this, there is a little bit of dust accumulation on some places, and I'll show you a little more of a close-up view of that in a second. So the ionization actually changes the particle forms, and then it drops dust. And so this is a couple of pictures to illustrate how the dust accumulates on other surfaces, taking it out of the air. And I'll show you a picture or two in a minute to show you how the air even looks different when you walk into the barns with the EPI system. Here's a picture of the dust accumulation on a line, and you start to notice the striations that occur right here where the dust accumulation is occurring. Same thing on some of the metal parts, in this case the pulley, the rope, even some of the sealing here. And then another pipeline here, you can see again the striation, the dust accumulation. So what you're doing is you're moving the dust to surfaces and taking it out of the air. And that was an intriguing concept to us, especially when we saw the poultry data that had been done before. And so Murphy Brown, we started to do this work about 5 years ago, and this work was released into public domain by Dr. Chris Rodemaker at the American Association of Swine Veterinarians in 2012. So today I'm going to highlight some of the initial data that was done on that. And what was done was there were over 44,000 weaned pigs placed in 2 nurseries coming from 2 different sow farms. The trials included 5 turns of the 2 nurseries with about 2,200 head per room, and the EPI system was set to come on at 12:30 a.m. and then go off with being off about 30 minutes. Now in the first turn or 2, that was still trying to be tweaked, and so the duration, the first couple of turns was a bit unique, but what we're trying to do is get the system to be on as long as you possibly can. The trial dates for this evaluation started in April 2009 and was completed in 2010. And in essence, the rooms were treated as the experimental unit with 10 samples per room. And at the same time, some additional evaluations were done on air quality, pulling gas measurements. 2 samples were collected from each room, and then multiple dust samples were collected throughout the test period to look at the different particulate size and the impact of the EPI system on dust accumulation. And you'll see a series of slides here, the effect on the various traits, and then you'll see the probability values here with the standard errors. And so in this case, there was a substantial improvement in daily gain, a significant improvement in daily gain, and frankly, overwhelmingly greater than we've probably ever anticipated that it would be. But in essence, taking what I would classify as reasonably good performance and making that better. Now, these pigs were weaned at about 24 days of age. And then when you look at what does that mean in exit weights of the nursery, significantly heavier, with about a 4.8 pound heavier pig at 45 days. Nursery mortality at this time was higher than normally had been, but it was significant using chi-square analysis and seeing a difference in mortality of 1.2%. And then looking at the various gases, hydrogen sulfide at day 45, you see a significant reduction with the EPI system. And that reduction is about 60%. The same with ammonia, and ammonia levels in these facilities are really quite low, moving it from 4 to 1.8 parts per million, and that was at a probability level of 20%, but still a 55% reduction in ammonia levels. And then looking at the dust particulate matter at day 45, the dust particulate is broken into 3 different particle sizes. The bigger particles being listed in green, the medium-sized ones in this pink, and then the smaller ones in blue, and then the associated standard errors for each of those particulate particle sizes. But the key message here is that the EPI system significantly reduced dust accumulation in the rooms, 43 to 58%, depending on the particulate level that we're talking about. At the same time, the Murphy-Brown group initially did some payback calculations, and what they did for this payback evaluation was to assume that they were going to take 80% of the research result value. So in the earlier test, you saw a higher exit weight advantage and more livability advantage, but only taking 80% of that, and then using their sensitivities showing that gives you a cost reduction of 37 cents per hundredweight, and then taking that through calculations and looking at the operating cost per turn, the updated EPI cost per room, and they initially suggested it was a 33-week payback. And more recently, with more current pricing, that payback has moved to a 42-week period. That particular study sets up the next part of the review was the group made a management decision to install the EPI systems into the nurseries in the Utah facilities. And what you see here is a statistical process control chart pre and post EPI installation. And the installation occurred in August of 2012, and you can see that over this 6-year period of time, there have been some increases in mortality, but the last couple of years, the mortality has been around this 2% mark and really on the bottom end of the confidence intervals. Over this 6-year period of time, the average is about 3%, but the last 2 years is just a little around, probably a little better than the 2% mortality. Now, there's lots of things that occur in addition to a change. You've got weaning age and other aspects, but what we're trying to do is just show, has the performance value maintained what you saw under research conditions with this kind of approach using an SPC chart. The same thing on daily gain. Daily gains earlier on was down around here. I see lots of daily gain in the industry today around this level. At this point, there was some increase in wean age, but you can see more recently daily gains are exceeding 1 pound and consistently staying in that range and starting to shift out of the confidence interval. And this red dot here means that you've actually seen a process shift. So kind of the takeaway, the research data showed that it was working. The subsequent implementation of the research shows that now you're maintaining really reasonably good performance. And I think the livability and growth rate in these nurseries, I'd probably classify it in probably the top 10 percentile of what I've seen across our industry. Now, what I'd like to do is maybe take a few questions, have them on that initial presentation, and then we're going to move into the review of the data that's been collected at Kansas State. Any questions that have come up, John?
I don't have any here on the Q&A. I don't have any text messages, so I think we'll go ahead and keep going.
Okay. Let me introduce the next part of our webinar today. Jon DeJong is a PhD candidate at Kansas State working with Dr. Joel DeRoshi, Uh, John is from Northwest Iowa. He was raised in the Orange City area on a small family farm where they had pigs. He received his Bachelor of Science degree from South Dakota State University. While he was going to school there, did an internship at New Fashion Pork in Minnesota, and then later was hired to work with them as a service person. And then he decided to go back to graduate school, finished his master's at Kansas State in June of 2013, and has started his PhD about a year and a half into his PhD, working on various factors that influence feed processing. And he says, Joel, he hopefully is to be completed by December 2015. So, Joel, it's been a real pleasure working with John, and John, we'll turn the time to you to go here.
Yeah, before I get started, Steve, we had 2 questions come in here while you were actually a couple more here. And if you can pull up the Q&A section there, Steve, you'll see them as well.
Okay.
Got a question here. What is your experience regarding the use of this technology on natural ventilated barns?
We're going to hit a little bit more of that into the finishing area. And all of these nurseries were, none of them were naturally ventilated. So the nursery work that was done was in conventional nurseries, and then we'll talk about some curtain-sided buildings in just a few minutes.
All right, then we got another one. Were the measurements of the 2 barns compared before the EPI system was placed in one barn? Basically asking if you made sure there wasn't a barn effect before the experiment was started there.
Yeah, that's a good question. And I mean, you routinely monitor room differences, but to say that was intentionally done that way and to verify there was not a difference, no, that was not done.
And then one last question from Gary Bradley. How do the people working in the barns like the EPI system?
Well, it's a new enough concept to them. It takes some adjustment, frankly. You know, all of a sudden there's this field of ions charged above their head. When you walk under it, kind of makes your hair tingle a little bit. And so you have to do some good education to make sure that people are not paranoid with the system and they recognize you're doing it to help the pig and improve air quality, and there is no negative effects on them if properly managed. Now, you know, if somebody took a scraper and hit that corona point, there would probably be a little bit of a tingle that would go like if somebody was to touch an electric fence. So there just needs to be some safety precautions put into place to avoid those kind of problems. Good questions. Thanks. Why don't we keep moving here, John, if you want to take her away. We'll pick up.
I'll have you work my slides here, Steve, but thanks for the introduction. Yeah, like Steve mentioned, we'll be going through some data here taken at Kansas State University, looking at the effects of EPI in a couple of nursery barns. Just a quick introduction today. I think we all know emissions from swine units and the in-barn air quality has been a problem in our industry for a number of years, and the odor that goes along with that as well. Airborne particulate matter is harmful and can carry odorous substances such as ammonia and hydrogen sulfide. And those substances, among others, have been shown in a few other previous studies to cause some health problems in both swine and human workers. So as Steve mentioned, we went over that Murphy-Brown data set, but they show reductions in mortality, hydrogen sulfide concentrations, and the number of dust particles in the air, which they believe led to improvements in average daily gain in body weight when the EPI system was used. There's also another study done in 2003 that showed EPI reduced dust in the farrowing houses by 50% in the farrowing house and then 36% there in the nursery. However, neither of those were significantly different. With that said, though, there is limited research that's been published. I know the Murphy-Brown data was at AASV, but after that, there's been little published data out there. And so we went ahead and conducted our own study here at K-State. I'm going to go ahead there, Steve. The objective of our study was to determine the effects of electrostatic particle ionization, or EPI, on hog barn air quality, emissions, as well as nursery pig growth performance as well. To go through and accomplish that objective, 5 6-week periods utilizing pigs that were 6 to 23 kilograms of body weight, so that's about 14 to 50 pounds body weight there, were utilized for the experiment. The EPI system was installed in 2 of our identical 200-head capacity nurseries here on campus or north of campus here in Manhattan, in our segregated early wean unit or SEW unit. We conducted about a 12-month study, and so we got a picture there on the bottom of the screen of what those two barns looked like. Each barn was equipped with 3 external exhaust fans, and so if you look there below the power cat symbol, you can see the exhaust fans there on the bottom of the barn. And then we also had 12 internal attic air inlets inside as well. So the EPI system through Baumgartner and Vironics was utilized in a single barn for 1 complete turn, and then it was rotated to the opposite barns to eliminate any effects or any barn effects that may have existed. And so that way we had 5 replications per treatment with barn as the experimental unit. At the beginning of each 6-week period, pigs were randomly allotted into pens between the 2 barns, and measurements were taken once weekly for the entire turn. Now, in order to take some measurements, dust particles were collected weekly inside the barn as well as at the exhaust fan outside of the barn for determination of the particle size of those air particulate concentrations, as well as the quantity that existed within the barn and in the exhaust air. Those particles were collected using that little instrument there on the right. It's a Lighthouse Worldwide Solutions handheld counter. And it was run at 4 different spots within each barn, down the middle aisle of the barn, and then at 1 spot inside the exhaust fan. And important to note that that was taken inside the barn at what we would consider the pig's breathing zone, so about 12 to 18 inches off of the ground. Looking at hydrogen sulfide, we used an Arizona Instruments little Jerome hydrogen sulfide analyzer, a little handheld device seen below there, which we used to measure hydrogen sulfide at 10 spots throughout the barn, also down the middle alley, and those were then averaged within barn for each week. We also took a few other measurements. We used the Draeger pump to measure ammonia concentrations in 2 spots in the barn on the 1st, 3rd, and the 5th week of the turn, and then those were then averaged within turn for analysis. We also took some dust samples from the barn and analyzed those for ammonia and hydrogen sulfide. The previous thought was that if the ammonia was coming out of the air, there's a good chance that it was probably going to be concentrated more in the dust, and so that's why we went ahead and took some dust samples and analyzed. And lastly, air samples were also taken on the 1st, 3rd, and 5th weeks of the turn using 10 milliliter vials, and those were then analyzed again for hydrogen sulfide as well as ammonia. So jumping right into the results here, we'll start off by saying the dust samples and any of the air samples that were taken showed no significant differences in either the ammonia or hydrogen sulfide concentrations that were measured there between the EPI or the control barn. Moving on here, this slide is going to depict what we saw in terms of inside dust within the barn. So we'll take a little bit to set the slide. On the vertical axis there, we have the particles that were measured per minute. And then on the horizontal axis, we have the 6 different particle sizes. So the machine was able to record particles from 0.3 to 10 microns. Most people would assume that anything under 10 microns would be considered respirable, so you can breathe it in. So then we have 2 bars within each micron size. The dark shaded bar would be the control barn, and then the striped bar would be the EPI barn. And if there's differing superscripts between the bars within a particle size, that showed a significant difference. So as we look at inside dust, we see that there was a significant reduction or improvement in air particulate matter as we go from the control barn to the EPI barn, and that was consistent across all 6 of those particle sizes that were measured. Here, we have no statistics on this side, but I just wanted to show you guys as we go through the turn, so from week 1 to week 6, we have the control barn. This is the average dust particles measured there at 0.3 microns. We see the control barn in the blue and the EPI barn in red. Just showing that as we go through the turn, we do see a slight increase in the dust that's present in the air, but that the reduction in the dust is pretty similar from week 1 to week 6 between the control and the EPI. And then we got a couple more slides that just simply show this at a couple different micron sizes. So we have the same thing, 2.5 microns, kind of in the middle there of the respirable zone. And then lastly, the next slide here, we also have at 10 microns. We see again that increase in air particulate matter as you go throughout the turn. So from week 1 to week 6, we see the same consistent reduction in particles in the air as you go from the control to the EPI barn throughout the 6-week turn there. As I mentioned, we took measurements at the exhaust fan, and so in order to do that, we'd shut 2 exhaust fans off and then only measure on 1 exhaust fan. So this slide's set up pretty similar to the inside exhaust. We see the particles. This is per cubic meter there on the left, and then we have the 6 different particle sizes on the horizontal axis there at the bottom. Again, control barn is the dark purple bar, and the EPI barn is the striped bars. So again, we saw significant reductions in exhaust dust as we went from the control barn to the EPI barn. The EPI barn significantly improved exhaust measurements there, and that was across all 6 of the particle sizes that were measured. As I mentioned, we did take ammonia concentrations using the Draeger pump. We saw no significant differences between the control or the EPI barn when we measured ammonia as well. In addition to that, let's go through the next slide here. The same pattern here holds true for hydrogen sulfide concentrations within the barn. We saw no significant differences between the control and the EPI barn when hydrogen sulfide was measured with the Jerome analyzer. However, and probably more importantly today, as we look at the growth performance of these pigs in the barn there, as we look at average daily gain, with the control barn being the dark orange bar and the EPI barn being the striped bar there, we saw a trend at a p-value of 0.09 for an improvement or increase in average daily gain as we went from the control to the EPI barn. That's about 30 grams, which would be about 0.15 pounds per day there if we look at that on a pound basis. And then because of that trend there for average daily gain, we also saw a trend at a p-value of 0.06 for an improvement in final body weight. These are listed in kilograms here. That's about 1 kilogram difference, so probably about 1.5 pounds there. It's a little less than a kilogram. It's about 1.5 pounds difference there in final body weight. Again, there was a trend for difference there for final body weight. And so in conclusion today, the EPI system here at K-State, we saw no significant effects on hydrogen sulfide or ammonia concentrations, but overall the EPI system was able to significantly reduce both in-barn particulate matter by 39 to 56%, as well as it significantly reduced barn emissions by 48 to 64%. As a result of that improved air quality, we believe that led to a tendency for improved average daily gain from the EPI system, which then in turn led to improved final body weights there at the end of those turns. That's all I have today there on the K-State data. I think we can, I got a couple of questions here, Steve, if we want to go ahead and go through those.
Please.
We got a note here from Gary Bradley. Those tests done at Murphy Brown, going back to that data set, were done with EPI and non-EPI in the same barn, divided into 2 separate rooms, so the same pig flow / time frame. Slap ventilation, etc., was used with 2 different barn styles, both split rooms within barn for EPI. So just a note there on that Murphy Brown data set. Quick question here, will the group provide the presentation to participants? Yes, we will have this posted online, hopefully here at some point on the EPI's website. I got a question on our data here at K-State. Why didn't we see significant reductions in ammonia and hydrogen sulfide? That's a really good question. There's probably, only speculation on our end, but our thoughts would be that 2 things. The first would be that being in a research barn, the air quality was pretty good to begin with. Really good air quality within both of those barns, so you maybe wouldn't expect to see as big of a difference in ammonia or hydrogen sulfide concentrations just because that air is so clean already being in a research setting. The second possibility would be that our testing instruments, which were different than the ones used in the Murphy Brown data set, maybe weren't as sensitive to differences that were present. But again, those would both be speculation on my part, but a good question.
John, you might want to clarify what your stocking density was in your test too.
Yeah, so in the research barn there, we would probably be considered understocked. Took the commercial average. We got 5 pigs and a 5x5 pen, so about 5 square feet per pig. A little less than that with the feeder in there. It's probably about 4.2 or so square feet per pig. And Steve, you can probably speak to what the industry average is in terms of stocking density.
Yeah, typically at that stage, you're going to see 2.5 to 3 square foot. So that may be adding to part of the difference in gas levels as well.
Yes, good question. Does the growth improvement occur beyond the nursery phase? And so I think we're about ready to get into some of the finishing data here. Steve, correct?
Yes.
Okay, so we'll get to that here in just a little bit.
And I think, John, is one of the standing debates within our industry is when you get heavier pigs out of the nursery, what does that mean in a total system? And, you know, the ongoing debate about compensatory growth and things. But I think most today would subscribe to the aspect you get a heavier pig out of the nursery, they get to market faster. And that's usually for 1 extra pound out of the nursery, may give you an extra 2 pounds at market weight is a very, very conservative estimate.
All right, got a couple more questions lined up here. We'll probably cap it here, then move on to the finishing data. We'll answer a few of these quick. Just again, ask what the reduction in dust emissions was there. So yeah, we saw emissions reductions anywhere between 48 and 64% there at the exhaust fan of the barn. We did, and then there's a question, did we measure barn ammonia emissions? And no, we did not measure emissions in terms of ammonia there. Not seeing any differences inside the barn. You would expect there would probably be no differences there at the exhaust. You're a wanted man, Steve. Here's a question for you. Does a reduction in dust usually equal a reduction in lung lesions or better health of the pig? Steve, did you get a chance to hear that?
Yeah, I did. And, you know, it's hard to know for sure. And, you know, I think the real critical thing when you're evaluating these technologies, even when we talk about viral and bacterial load reduction, if it doesn't translate into pig performance benefit, it's a bit academic. And so what I'd really suggest to the audience today is those other things start to explain the possible mode of action, but what you're really trying to say is how did the pigs react to the environmental conditions they're placed in? I think, John, with that, let's move on here and continue the discussion. And so up to this point, what we've tried to do is say the earlier test done at Murphy Brown, the work done at Kansas State, and about the same time, the Baumgartners contacted a group, Cooper Farms, to do an experiment as well in the nursery. And in this case, there's about 60,000 weaned pigs, and they were housed in 30 different commercials, nurseries with 15 different lots per treatment. And this was done over about a 2.5-year period of time. And you can see the pigs came in at about 12 pounds, and you can see the differences between the EPI and the control group, and then the probability values here. But in this case, you see a significant improvement in daily gain, a significantly heavier pig, about 3.5 pound heavier pig. Not as great as the Murphy Brown data said, but greater than what was shown in the Kansas State data. So what this would suggest is you have 3 studies that line up and show a strong tendency for improvements in gain in the nursery. And notice in this particular experiment, excellent livabilities, even though the pigs are fairly light coming in and gains are relatively average here, but the livability was tremendous. And so what we're trying to do is show today the whole body of work as a progress report. And I think conclusion 1 here thus far is the most data that we have on EPI today is the strongest in the nursery, showing benefits there, primarily in the way of weight gain and a slight improvement in mortality if mortality rates are a little bit higher than what one's desire. What we'd like to do now is switch to the finishing wean to finish area, and this is some work done at New Fashion Pork in finishing. And what you have here is about 8,000 feeder pigs, and these pigs came from the same flow, double stocked in the nursery, and then comparing building with 8 different lots. And you can see that in this case there was a a slight improvement in market weight, though not significant. You see a tremendous improvement in feed efficiency, frankly, more than one would have ever anticipated, and a reduction in mortality. And when you take this difference in mortality, typically in the past, 5 to 6 points of feed efficiency is equivalent to 1 point on mortality. So about 50% of this difference in feed efficiency can be explained by this mortality difference. So in this particular study, showing in this finishing phase that you are seeing an improvement in feed efficiency, a tendency in gain, but the gains were not significant. And then when you look at the next, this is another set of data that came out of new fashion. Interesting enough, this was a group of pigs that were challenged with PRRS, and you see the real fall off in gain and mortality in the control group. And with the health challenge there, you see that there was a significant improvement in gain, an improvement in feed efficiency, and improvement in livability. And again, this difference in mortality, again, the feed efficiency differential is enormously big here, and bigger than I think one would have ever expected, and probably about 40% of the feed efficiency difference can be explained by this mortality difference. So I think what is showing in these two new fashion tests, that there's some indication that it's working in finishing, and these buildings were all conventionally ventilated systems. And then another test that was done at Audubon Manning Vet Clinic, less replicates, only 3 per treatment. In this case, there's not statistics done on this group, represent about 7,400 feeder pigs. And what you see here is a heavier market weight, about 5 pounds heavier market weight, 1% more increase in full value pigs, reasonably good daily gains, excellent feed conversions, and reasonable mortality levels. And so I think this group would conclude that it showed some intriguing benefits on 2 areas on extra market weight and as well as more full value pigs. Now this is a study that is currently underway, and I position this one to you as a progress report evaluating EPI systems in wean to finish, and these are more tunnel ventilated systems. And you see there's no significant differences with these 16 lots at this point. This test is continuing to be collected, but you see that there's really a pretty high standard error in these analyses. You see a little heavier market weight, feed efficiencies pretty comparable, livability is probably a little worse than you'd expect, and these were all sourced from the same flow, and these are all pretty much P1 offspring as well, adding to part of the growth challenge and livability challenges of these particular animals. And it's probably adding to the standard errors, making the test not significant, but at the same time wanted to show you the whole body of work to say in this particular test there's no significant difference at the time, and it's still continuing to progress. Now moving into a little more of the data that has been done more from an academic perspective. This work comes from South Dakota State, done by the engineering group there, and what they did was put the EPI system in and evaluated it in the nursery, the grower, and the finisher, and compared it to no EPI or with EPI. And you can see that in each of the phases there was reductions in dust. But I thought it was particularly intriguing to see more dust in the nursery phase and in the finisher phase in the growers. And those of us that have been through and seen that under commercial conditions, that's really pretty cool. So I think what this data would say is they're clearly seeing a dust reduction in this evaluation. The University of Minnesota has been evaluating the effect of the EPI technology on PRRS, PED, and influenza virus, and what does that system do? And this is a test that is very much underway, And the summary of that data at this point would suggest the total removal efficiency by viral type. So you're seeing anywhere from 84 to about 96% reduction in influenza PRRS and PED levels. Now, the fundamental, they concluded the EPI technology was effective in decreasing airborne PRRS, influenza, and PED virus. At the same time, we really don't know if that says anything about pig performance. That might be a 2-log change, and is that enough to result in improved pig performance? So I think it's really important to clarify from this point that there's some indication that it is reducing viral load, but does that translate into production benefits? Additional work done at Manitoba using some more evaluations looking at the effect of EPI on PRRS virus concentration, and done under 2 different environmental conditions. And the real takeaway here, similar to the University of Minnesota data showing about a 95% reduction in viral loads, again, not extrapolating that to pig performance, but simply saying, yeah, it's taking the viral load down in these 2 environmental conditions. Another piece of work that has been going on in Quebec, and what they've been looking at is the impact of the use of the EPI system on biocontainment, in essence saying how do we minimize the spread of virus, and comparing an EPI system to a filtered system and looking at the primary components of that biocontainment and showing that the EPI system is getting a pretty good fraction that would be comparable to the filtered systems on dust particulate, total dust concentration, and bacterial load. So at this point, again, it's some intriguing information. And again, that's just, we've got to be careful. We just say, what does that really mean from a production standpoint? It means probably less dust and less bacteria being emitted to the air. And then the challenge becomes, does that affect pig performance and affect the economics at the farm level? Now, moving into the broiler work, this was some of the work that we viewed and caught our attention early on. And this was work done by USDA researchers, even going back to 2004, looking at percent reduction compared to the control. And in this particular test, they're showing airborne dust, ammonia, and airborne bacteria all were significantly reduced at the rate of about 56 to 67%. So pretty big reductions in those 3 components in broiler houses. And then looking at some work that more recently done by Bittman and Associates in 2009, done at British Columbia and reported at the Sustainability Agriculture Conference there. They showed a 3-point improvement in feed efficiency in broilers. No statistics were done on that particular data set, but in that report, they're reporting they saw a 5-point value per bird, and giving a 2.2-year payback estimate was what was concluded from that. And at the same time, showing very similar work that was shown in the pig area on particulate matter, seeing significant reductions in levels of the 3 different particle sizes here, between 44 and 47%. So I think you're clearly seeing a clear lineup on dust reduction across this data set. And this particular picture was part of that evaluation, and you can see this kind of haze that occurs in the facility, and then after EPI you see a little more of a clearing. I've seen this same phenomena occur in pig operations. It's a little hard to capture these kind of pictures, but you truly do see a little, particularly these longer buildings, you can see how much clearer the end of this building is compared to the end of this building. Again, just trying to give supportive evidence that you do see a bit of a visual difference in that dust reduction. And the USDA researchers back in 1999 concluded that reducing airborne dust levels may thus offer an opportunity to limit the spread of salmonella throughout poultry flocks. And so that was part of the reason they started doing this work in the late 90s. Okay, kind of moving to the final part of our presentation, oftentimes you say, okay, here's what the research says. So what does it mean from a value proposition? And everybody has their own methods to do financial evaluations. What I'm trying to do is just show you one that we've looked at and try to share with you, at least to stimulate thought on your part to say, is this a cost-effective technology for you to consider? And to begin with, laying out the assumptions that we're going to assume a nursery gain. Pigs out of the nursery are going to be 2.5 pounds heavier, resulting in 5 pounds heavier at market weight and 0.5% livability. So taking a part of the combination of those three groups, using economic cost sensitivities, suggesting that 1 pound heavier market weight is equivalent to about 17 cents per pig, and 1% livability is equivalent to about $2.50 per pig. And so the value of that calculation, when you put the weight value, the livability benefit, you get about a $2.10 value by getting this extra 2.5 pounds out of the nursery and 0.5% improved livability. Now the associated cost, the cost to install an EPI system today is about $9,500 per. This is for a 2,000 head nursery, and making the assumption that you're going to turn that nursery 6 times a year over 5 years. So you've got an amortization schedule of 5 years, and so you've got a cost of the capital of $316 per turn, and an operating cost, time you do the maintenance, the electricity cost, all that stuff of about $50 per turn, and an estimation cost per pig of about 18 cents. So when you divide that out, you get about 11.6 return over cost. And what's intriguing, when you take that one step further and say, okay, what do you need to do to break even? 1 more pound of market weight here gives you close to that cost of operation. So from my standpoint, we know that we have needs in improving our ventilation systems. The EPI system, I think, can especially add to the value in areas that we have questionable ventilation, like in a tight nursery, maybe in a tight finisher, and may ought to be looked at as a possible solution there. So in summary, what we've tried to review with you today are the following takeaway messages. One is there's pretty clear evidence that it reduces dust, and there's a strong tendency for improving gases when they're evident there. There's some 3 pretty well demonstrated tests showing strong tendencies for improved nursery performance, especially on growth rate. Some of the recent data showing decreases in viral and bacterial loads. Shows promise for wean to finish and finishing operations. The data is still not as conclusive there as it is in the nursery, but I think it may be in conclusion suggesting to you the whole body of work continues to grow, demonstrating production benefits, and one that I'd encourage people to kind of keep this on their radar screen. So with that said, John would be happy to respond to any additional questions, and please jump in at any time when the questions come up as well.
All right, we got a slew of questions here, Steve. Kind of one that's come up a couple times here. Made a good point here and a question that we're talking about airborne reductions in viral load, but what about reductions in overall virus in the barn? So we think about that dust that exists that we're pulling out of the air, it's going to have some virus in it. So maybe you can just comment on the effect the EPI would have on total virus that pigs come into contact with, and not just the airborne fraction of that.
Yeah, I guess I really understand the theory and the extrapolation, but at the same time, really don't know what it does, John. I would suspect that if we're reducing dust, there's just less vehicle to have total viral load carried on it. That's probably going to have some benefit. But does that translate into faster growing pigs and give me a payback? That becomes the question.
All right, and if that didn't answer that, those few of you who are asking that, go ahead and maybe send another question. We'll see if we can get it answered still. Another question here, Steve. Would you expect the same results in a high health status barn as compared to a low health status barn? And where do you think that good zone is in terms of where this system should be implemented, whether we should only implement it in our low health status barns, or where do you think that fits in?
I think that's an excellent observation and question. And the new fashion data is pretty intriguing to show that in those PRRS challenge barns, they saw a pretty nice benefit. But it's like anything else, I think, in life where you have a problem and you need better solutions. You would anticipate that when you have dust, you have viral load and health challenges, you may likely see greater problems. And I think we've all seen seasonal problems with ventilation. You know, when we have good weather and we've got buildings open, we don't see the performance and the respiratory challenges that you do when you see pigs coming out of winter months, for instance.
Another question here. This is probably for our KSU data. I think this was an earlier question. If we saw any humidity effects on dust during the winter, we didn't measure humidity effects. In terms of reduction of dust particles, that response was pretty similar, whether it was winter or summer months throughout that year that we were taking data there. So we probably didn't see as big of an effect of humidity on the EPI system reducing dust. Got a question here from Gene Gurley. What's the normal variation between barns and at KSU in terms of performance? And he's pretty much saying if we had enough replications to show that. And Gene, I was talking to Joel here, kind of in between here, and we've noticed that we've taken data on those barns for the last 10 years. We've never seen an interaction or a barn effect between those two barns. We don't expect that they're different. But in order to get those results to be significant, so the average daily gain in body weight, we'd expect probably 3 to 4 more turns. We'd be getting towards a significant effect there on average daily gain in body weight. I had a question via text here. If there's any indication of reduced odor emissions with the reduced dust, ammonia, and hydrogen sulfide concentration. And Steve, I'll maybe ask you that first. If there's been any evidence of reduced odor emissions.
The odor has not, to my knowledge, been routinely quantified, but logically, I think anytime we're reducing dust, that becomes the vehicle for carrying the gases on it as well. And I've seen that under commercial conditions, that when we have less dust, we have less odor in a given peripheral area. So I would suggest that's probably likely, but it has not really been clearly demonstrated.
All right. Question earlier, I think from the K-State data set, was there any analysis of morbidity or mortality between the groups? In the K-State research facilities, we're, I would consider extremely high health. I'm actually the manager there out at these two nurseries, and we run anywhere between 0.5% to 1% mortality for each turn. Just had a group go through with one dead on over 400 head there. So we're really low on the mortality there. So we did not see any differences in mortality, but you probably wouldn't expect any differences just due to the fact that we are such a high health facility.
John, going back to that earlier question on odor, I just recalled the work that we did in the building, not emitted from the building. We had submitted some samples to Iowa State to do olfactometry on, and we did see an odor reduction in odor intensity, and that, you know, I think was pretty well correlated to the dust and gases as well. So we elected not to show that data, but yeah, there was some odor intensity analysis done in that Rodemaker evaluation.
Another question here, Steve. Is anyone using this for viral load reduction in sow farms? Do you know of any work that's being done there, specifically at the sow farm and reducing viral loads?
Yes, there is some evaluations occurring at a couple locations right now, looking at the effect even on sow productivity, and then I think they'll be monitoring viral load. So that is presently under evaluation. It has some interesting potential there, but the data say that we have clear data to show that it is helping. We do not. And again, it gets back to the whole question is, if we get a 95% viral load, is that enough to see a difference in pig performance?
Yeah. Kind of going back to the question on naturally ventilated barns, Steve, I don't know if you can touch on that.
I think, you know, in a lot of the naturally ventilated barns, especially in finishing, you're going to have less opportunity to get an EPI benefit. You know, you've got more fresh air movement through ventilation generally is going to be better. But the question then becomes is when you're tightening those up, when you might have some young pigs in it, or you have you're coming out of winter months or something like that, there's probably some benefits. So my guess, and it's only a guess and an estimate, that it probably would have less efficacy in more temperate zones where there's more natural ventilation.
Another question here, Steve. Mark Finn asking, we didn't touch on worker health and safety. Says there's most likely some cost saving and reduced sick days and maybe even reduced worker turnover. Maybe you can comment just a little bit on that aspect in terms of worker safety and health.
I think there's that theoretical benefit. At the same time, the dust is still in the room. And so in many cases, as you work with the EPI system, you know, the dust then moves from in the air to almost an irritant in your work zone. So if you happen to hit the feeder, it gets in your face. And so it doesn't totally eliminate it from the workplace. Yeah, there's, again, some nice theoretical aspects of that, but I don't think there's any indication to suggest there's a health claim to employee health by using it.
All right. A couple more here. Steve, maybe you know this better than I would. What is the, I know it's only been around for not too long, but what is the typical lifespan of the EPI system and maybe some general maintenance that's involved with it?
Yes, that's another really good question. And we've had that same dialogue with the Baumgartners, and they tell me that the equipment is designed for 10 years worth of capacity. I've had engineers tell me stuff like that in the past, so I divided it by 2 to create a little more conservativeness, and that's why we did the value proposition based on a 5-year. I think there is going to be a little bit of ongoing maintenance in the replacing of parts. You know, anytime you have those kind of moving parts, there's going to be a little bit, but it's pretty low maintenance kind of stuff. What you're doing is you're just taking electricity and generating ions from it, you know. And so
I would probably reiterate that. It's a pretty simple system in terms of moving parts and such. Power wash are safe. So, but yeah, I think they say 10 years. So if you cut that in half, 5.
What was your experience in managing the dust, John, in the nurseries?
In a research setting, I think it's a little different. We've got really small pens that we need to get into to weigh pigs once a week. So that dust that's on top of the pen that's not in the air, as soon as you get in there and start weighing pigs, that dust has a tendency to get back up in the air once you start rattling everything around. I don't see that happening probably in a commercial barn where you're not as confined and there's not as much gating everywhere. But in the research barn, it's a lot of gating. So there's a lot of places for that dust to collect that gets in your way. But other than that, working the system, really easy. If you're not, you know, throwing pigs around and trying to get them weighed, really good and really easy to work around, really easy to get out of your way. If I need to go in and treat, gets out of the way pretty fast. It's on a winch system, so it takes a couple seconds to raise it up and you can go inside and treat, and then get it out of your way and then put it back down once you're done.
I think that would concur with our experience as well, John. And I mean, there's sometimes you're going to go in and vaccinate a group of pigs, for instance, or treat a group of pigs. And what we found is you just take a simple leaf blower and go in and blow down the room for 2 or 3 minutes before you start doing the work, and then move the dust, because it's going to move into the pit easier than it would. And so it does take a little bit of the irritant out of it by just taking a blower in and knocking a little bit of it off before you go in and start to get it all over you. But it does change the environmental conditions of the room as shown as those earlier pictures.
Yeah, I would also add to that, and I think maybe some work's going to be done here in the future, but looking at cleaning time with all that extra dust there on the pens, looking to make sure we're not significantly changing the cleaning time of the barn, but there's no data or anything on that yet. So,
yeah, and I think I looked at some of it, John, and it really, I mean, it's so easy to handle it, it doesn't really change it much.
We've got one last question here. Steve, this is for you. Do you have a feel for market penetration of the EPI system in nurseries? across the states here?
Yeah, that's another excellent question. I'd say it's still early phase of technology. I think market share is still rather limited. I'm not sure what it is. I'd have to really rely on the Baumgartners to tell us that, but it's still relatively small. I think there's been some international markets that have started to embrace it as well. But I think the data is now starting to come together, and it's going to, I believe, is going to continue to grow market share. I would guess today it's relatively small though today.
All right, Steve. Well, that let me see. I just checked my email here. I had a couple questions on email, but I think they've been addressed. So that's all we have for questions here.
And John, I mean, if anybody would like to talk more about it, I'm sure they can talk directly to Matt or John Baumgartner if they're interested in getting a price estimate for the system, or you or I are available to help them with technical questions as well. So thank you, John, for organizing this for us, and thanks to the participants for taking a little bit of time out of your life today. Thank you. Take care. Bye-bye.
Thank you.